Okay. Bismillah ar-Rahman ar-Rahim. We'll continue doing this. These sections, 5.1 to 5.3. We did all of these ones, all of these examples. Now we'll start the old exams questions. That will be the first one. If y equals C1, this is the solution. Is a solution of this initial value problem. So he mentioned it's a solution. Now we need to find the C's. Really need to find the C's, giving these initial conditions. So I need to find y prime. Or let me write y here. C1 cosine ln x plus C2 sine ln x. So what is y prime? It will be C1. What is this? Minus sine ln x, derivative of ln x, which is 1 over x, plus C2 cosine ln x times derivative of ln x, which is 1 over x. Okay, now I have y at 1 equals 7. That implies what? Substitute. Ln 1 is 0. So cosine 0 is 1. I have C1. Ln 1 is 0. Sine 0 is 0. That will be 7. Good. Y prime at 1 equal to, I have what? Now, ln 1 is 0. Ln 1 is 0. Sine 0 is 0 over 1. So it's 0. So I have C2. Here I have what? Ln 1 is 0. Cosine 1. Cosine 0 is 1 over 1. That will be 1. That's equal to 2. So what is C1 plus C2? 7 plus 2, which is 9. Easy one. What should the following set of solutions, homogeneous linear differential equation, is linearly independent? It's linearly independent. This is dependent. This is linear dependent, since it has 0. So you have C1 times 0 plus C2 sine x plus C3x equals 0. I will choose this to be 1. This is 0. This is 0. So I'm getting 0. This one is also dependent. Oh yeah, this is dependent. This is dependent. This is dependent. I will prove these things. 17. In the exam, no need to do that, but just since I'm explaining it. What I need, sine square plus cosine square is equal to 1. This is what I have in my mind. So let me use a different color. So to make it like this, I will take C3 to be 1 over 3 and C2 1 over 2. So I have sine square plus cosine square, which is 1. I take C1 1 over 70. Or minus 1 over 70. So I have minus 1 plus 1 equals 0. So they are linearly dependent. Next one, this is 2. This is 3. 4. Yeah, I know that cosine x minus sine x or plus sine x is equal to e to the power x. Yeah, I know that. Since cosine hyperbolic x plus sine hyperbolic x is e to the power x plus e minus x over 2, and that minus x. So this is cancelled. So I have 2ax over 2, which is ex. So that's correct. So I will write this C1 ex plus C2 cosine hyperbolic x plus C3 sine hyperbolic x equals 0. So I will choose C1. This is 1. So cosine hyperbolic is e to the power x. I'll choose this minus. So I'm getting it. The fifth one, I'll use which formula? I know that cosine 2x is 2 cosine square x minus 1. So this is what I want. So what is it? C1 times 17 plus C2 times cosine square x plus C3 times cosine 2x is equal to 0. Now I need to choose C's satisfying these things. So I'll make this one. So I have now 2 cosine square minus 1. I need to cancel this. So choose this to be -2. So -2 cosine square plus 2 cosine square will be 0. And I will choose this to be 1 over 17. So you have 1 minus 1, which is 0. So now all of this linear independent. And this one is very clear, is linear independent. And I can show it using the, if you want a proof, using the Wronskian 100. No need for that, but if I want to show you a proof, that give me what? I'll do this with this. So I have e to the power x sine hyperbolic minus e to the power x cosine hyperbolic. And then I know in cosine hyperbolic minus sine hyperbolic will be e minus x. So that'll give me e to the power x sine minus cosine, which is minus e minus x. That will be -1, not equal to 0. So for sure, this is linearly independent. Actually, it's very clear. Okay. I want to solve this equation. I have the auxiliary equation, r to the power 4 plus 3r squared minus 4 equals 0. I can factor it. That will be r squared. I need plus 4 and minus 1. Is it -4 minus r squared plus 4r squared? That will be 3r squared. Correct. So I have r squared minus 1 equals 0. So r equal plus or minus 1. I have r squared plus 4 equals 0. So r equal plus or minus 2i. So what is my general solution? Y equals c1 e to the power x, c2 e minus x, c3 cosine 2x, plus c4 sine 2x, which is this one. Exactly. This is the general solution of this equation. I notice this equation, it's constant real coefficient. So if they have sine, for sure g of x will be what? E minus x cosine x. Yeah, right away. Since if I have -1 plus I is a root, then -1 minus I is a root. So you have the one with the sine and the one with the cosine. So this will be g of x. So what are my roots? The roots are a from here and -1 plus or minus r. Okay. I need to factor this, which is very complicated. But since I know -1, which means a -1 plus I -1 minus I. Since I know these are zeros, then I can use synthetic division to reduce the equation into first order differential equation. This will be 9, 11, 4, minus 14. I will try to start with this, -1 plus I. I'll have what? 9. That will be -9 plus 9i. So it's what? 2 plus 9i. I need to multiply -1 plus I times 2 plus 9i. That will be what? -2. Let's do it in a good place. -1 plus I times 2 plus 9i. That will be what? -2 plus 2i minus 9i plus 9i squared, which means it is -11 minus 7i. -11 minus 7i. Add, you have what? -7 minus 7i. Now we need to multiply this, -7 minus 7i times -1 plus I. You will get what? 7 plus 7i minus 7i minus 7i squared, which is 7. 7 plus 7, so you have 14, 0. So this is correct now. It's a 0. Now we'll use the second one, minus I. I have 9. So you have -9 minus 9i. That will be -7. Multiply. I'm getting 7 plus 7i, which is 0. So the new equation will be nine r minus 7 equals 0. So r will be what? 7/9. So my a, this will be 7/9. And that's the answer. I wish it's clear. This is the general solution. We have now the general solution, and he wants the differential equation. Okay, what I have from here, what are the roots? 2 repeated and minus 2. So what are the factors or the auxiliary equation? Let me say the auxiliary equation will be r minus 2 square r plus 2 equals 0, which is what? R square minus 4r plus 4 times r plus 2 equals 0. So you have r cubed, you have minus 4r square plus 2r square, that will be minus 2r square. Concerning r, I have what? This times this minus 8 plus 4r, that will be minus 4r. 4 times 2, that will be minus 8 equals 0. So it will be the differential equation, third derivative, second, first derivative, plus 8y equals 0. Which is this one? The Wronskian. You want the Wronskian of these functions right away. 1, 0, 0. This is x. This is 1. This is 0. This is x squared. This is 2x, 2. This is the Wronskian of f, g, and h. And that will be determinant. I cancel this. I have 1 times this, which is 1 times 2, which is 2. Is that will be true. It be a solution of this initial value problem. Find y at lim 2. Okay, let me do the calculation. First, I need to solve this equation. I have the auxiliary equation. R squared minus 4r plus 3 equal r minus 3, r minus 1 equals 0. So I have r equal 1 with 3. So the general solution, c1 e to the power x plus c2 e 3x. I need to apply this. So I have y prime will be c1. I think we did this before. It's okay. This will be y prime. So I have y at 0 equals 7. So I have what? C1 plus C2 equals 7. Y prime at 0 equal 11. So I have what? C1 plus 3C2 equal 11. I can multiply by minus 3 in this one to have what? Minus 3C1 minus 3C2 equal minus 21. And I have C1 plus 3C2 equal 11. So I have what? Minus 2C1 equal minus 10. Am I right? Yeah. So C1 equal 5. Plug it here. C2 equal 2. So my solution, y equal 5 e to the power x plus 2 e to the power 3x. Now we need to find y at ln 2. That will be 5e ln 2 plus 2e 3 ln 2. That is 5 times 2. E ln 2 is 2. This one will go as a power. So I have 2 times 8. So it's 10 plus 16, which is 26, which it is. A linear homogeneous constant coefficient equation with general solution is this. This is now the general solution. So what are the roots? R2, and from here I have plus or minus 2i. Okay, so it will be the auxiliary equation. R minus 2, R minus 2i, R plus 2i equals 0. In other words, R minus 2 times what? This is R square minus 4i square, so it's plus 4 equals 0. And that give me what? R cubed minus 2r square plus 4r minus 8 equals 0. So it will be the differential equation. Triple. Second. Which is this one? Yeah, easy. Find the general solution of this differential equation. It's written in as a different as in terms of operators. So I need the roots. Here I have 1, 2, 2. Here I have plus or minus I. Here, let me do it. I have r squared plus 6r plus 13 equals 0. So I have what? R will be minus 6 plus square root 36 minus 4 times 13 over 2. We did it before. This will minus 6. This is minus 16, so it will be plus 4i over 2. That minus 3 plus or minus 2i. So I have minus 3 plus or minus 2i repeated 2 times because of the square. So what will be the general solution? Y equal C1 e to the power x plus C2 plus C3x e to x plus C cosine x plus C5 sine x plus I have C6 plus C7x e minus 3x cosine 2x plus C8 plus C9x e minus 3x sine 2x. So I have this, I have this, this, and this one. So I have everything. The general solution of this differential equation is, so I need to solve this equation or the auxiliary equation, which is 2r cubed minus 2r squared minus 2r equals 0. So I have what? I can take r common factor. I have 2r squared minus 2r, 3r minus 2 equals 0. Now I need to factor this. I have 2r and r. I need minus 3, so I have minus 2 plus. So I have r minus 4r, that minus 3r minus 2 to r squared. Perfect. So the roots are 0 minus half 2. General solution, C1 plus C2 e minus x over 2 plus C3 e to x, which is this. C2, C3, it's okay, no problem. Which set of is linearly independent? Is linearly independent. So I need to prove the ones which are dependent. This is, I will start with E. So I have C1x plus C2 sine 2x plus C3 sine x cosine x. Which formula should I have in my mind? Sine 2x equal to sine x cosine x. So with that in my mind, I can write this is 1. So I have 2 sine x cosine x, write this minus 2, and this make it 0. So I have 2 sine x cosine x minus 2 sine x cosine 0. For sure, that will be equal to 0. So this is linear dependent. D, I need C1 times 0 plus C2 cosine x plus C3 e minus x equals 0. If I have 0, that will make it easier. I'll take C1 1, the rest I take it 0. So I can do this. So this is linear dependent. C, I have C1 times 5, C2 sine square x plus C3 cosine 2x. Which formula should I have in my mind? Cosine 2x equal to cosine square minus 1. That's what I should have in my mind. So this is 2 cosine square minus 1. No. I need, sorry. I need this with the sine. Not with the cosine. So I need 1 minus 2 sine square x. Okay. And this one will be, what I need is 1 minus 2 sine square x. Sorry about that. If that is minus 2, it will make this 2. So you have 2 sine square minus 2 sine square minus 2 sine square. It will be 0. I have 1, so I'll make this one minus 1 over 5. So I have minus 1 plus 1. That will make it 0. Now I have D, B, I mean. Let me do it here. B what is it? C1 times 1 plus C2, 2 minus x squared plus 2 minus C3, 3 plus x squared equals 0. Yeah, I want to make this. Yeah, I can do it easily, I think. I'll take this as 1. So to cancel x squared, I will make this 1. So I have 2 plus 3, that is 5. I'll take this minus 5. So that will make it 0. So this is also linear independent. Now the first one, for sure, this will be linear independent. Yeah, for A, I'll do the Wronskian to be sure. x1, 0, x squared to x2. That give me what? 2. Cancel this with this. I have 1, 2x, 0, 2. So I have 4 not equal to 0. So it's linearly independent. Yeah, I think that will do. I need to find the equation which satisfying this. So what are the roots? 2, 2, 3 times. Auxiliary equation will be r minus 2 cubed. I know the formula for a minus b cubed. That will be what? R cubed minus 3 r squared times 2 plus 3 r 2 squared plus or minus 2 cubed equals 0. So I have r cubed minus 6r squared plus 12r minus 8 equals 0. So the differential equation, y triple minus 6y double prime plus 12y prime minus 8y equals 0. Okay, solve this equation. Yeah, I need to do what? I have 2r cubed. This is the auxiliary equation. 2r cubed plus 5r squared plus 3r plus 2 equals 0. Yeah. If I do b over q, I have a0, 2, an 2. So p equal plus or minus 1 plus or minus 2. Q will be plus or minus 1 plus or minus 2. So b over q will be plus or minus 1 plus or minus 1 over 2 plus or minus 2 plus or minus 1, which is already there. No need to. For sure, the positive one will not do it because it will be plus, 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 plus. So I need to concern about so I shall concern only with the negative ones. So check minus 1 r equal minus 1. What I have? Minus 2 plus 5 minus 3 plus 2 not equal to 0. I check r equal minus 2. I have what? Minus 16. 5 times 4 plus 20 minus 6 plus 2. That will be 22 minus 22, 0. I get a 0. That's it. So now I will do the synthetic division over 2 over minus 2. That will be 2, 5, 3, 2. 2 minus 4, 1 minus 2, 1 minus 2, 0. That's it. So this is the new equation. So I have 2r cubed plus 5r squared plus 3r plus 2. This shall equal to r plus 2 to 2r squared plus r plus 1 equals 0. I need to solve this. So I have r will be what? Minus 1 plus or minus square root b squared 1 minus 4ac minus 8 over 2. That is minus half plus or minus square root 7i over 2. Okay, so what are the roots then? Minus 2 minus half plus or minus square root 7i over 2. General solution, C1 is minus 2x plus C2 is minus half x cosine square root 7 over 2x over, no, this is 4, sorry. Since A is 2, huh? So this is 4. Sorry. That will be 4. That will be 4. A is minus 1 over 4x sine square root 7 over 4x. Yeah, A is 2. Huh? A is 2. And usually you have A is 1, so we write 2, but we need to be careful. R is 4. Huh? The denominator should be 4. That will be the answer. Just this one. Okay. The graph of the solution of this initial value problem. What I want to solve this. Find the solution. So I have the auxiliary equation, which is an easy one. R squared minus 1 equals 0. So R equal plus or minus 1. Very clear. So the general solution. Okay, I need y prime. Let me find y prime, which is an easy one. So I have y at 0 equals 0. That implies what? This one will be C1 plus C2 equals 0. Y prime at 0 equal 2. So I have C1 minus C2 equal 2. Add them to C2 equal 2. So to C1 equal 2. So C1 equal 1. If C1 equal 1, what will be C2? Very clear, minus 1. So my solution will be what? AX minus AS minus X. That will be my solution. Now we need to find for sure ln 2 or ln 3. One of them will do it. So let me start with ln 2. I have A ln 2 minus AS minus ln 2. And that will be 2 minus half, which is 3 over 2. So this is the correct answer. This is wrong. This is wrong. Also, if you do ln 3 for completeness, ln 3, that give me what? 3 minus 1 over 3, which is 8 over 9. 8 over 3. Yeah, 9 minus 1, 8 over 3. Oops. This is wrong, and this is wrong. So A is the correct answer. Okay. A linear homogeneous differential equation, the following solution. Yeah, let's see what everything as a solution. So the roots 2 plus or minus 2i. I think we did something similar. Yeah. He says his general solution or his solution. Since he wrote all the solutions, there is nothing I can add. So let me do it. Auxiliary equation will be r minus 2, r minus 2i, r plus 2i equals 0, r minus 2. This is r squared plus 4. So I have r cubed minus 2r squared plus 4r minus 8 equals 0. So the differential equation, which is this one. Find the general solution of this equation. So I need to find the roots first. It's ready. I have 1. Here I have minus 2 repeated. Here I have plus or minus 3i repeated 2 times. Huh? Okay. So it's the general solution. Oops. The general solution. Y equals C1 e to the power x. C2 is minus 2x plus C3 x is minus 2x. This one sine cosine. I have C4 plus C5x with cosine 3x. C6 plus C7x with sine 3x. Yeah, so I have this. I have everything. So that's will be the general solution. This function is the general solution of which equation? Now I have the solution, general solution. So what are the roots? The roots are, this is 0. This one I have alpha is 2 plus or minus I. That will be my roots. So What will be the equation or the auxiliary equation first? Let me do the auxiliary equation. That will be r minus 0, r minus I, r minus 2 plus I is equal to 0. So you have r, and what is this? R minus 2 square minus I square plus 1 equal to 0. So you have r square minus 4r plus 4 plus 1 plus 5. So you have r cubed minus 4r square plus 5r equals 0. So it will be a differential equation, triple second derivative y prime equals 0, which is this one. Okay. Yeah. Let me do more. As two parts, consider this initial value problem. As a solution, he gave me the solution. He gave me the solution, e to the power x cosine sine. Prove that the functions are linear independent. This is the first things. He wants me to prove they are linear independent. So I need the Wronskian, y1, y2, y3. Wow. I need e to the power x, e to the power x, e to the power x, cosine x, minus sine x, minus cosine x, sine x, cosine x, minus sine x. Yeah. Okay. What shall I do? Do one trick I can do, since they are solutions, so the Wronskian for any x, either it will be equal to 0 or not equal to 0. So I will take x equals 0. So this one, w, y1, y2, y3 at x equals 0, that will be what? 1, 1, 1. This is cosine 0 is 1, 0, 1. That will be 0, 1, 0. So the last column will be easy one to deal with. So that will be, I'll deal with this column. So I have plus, minus, plus. This is minus. So I have minus 1. Cancel this with this. I'm getting what? Did I do a mistake? Cosine x minus sine x minus cosine x. Sine x, only cosine x minus sine x. At 0, I have e to the power 0 is 1, 1, 1. I have cosine 0 is 1, 0, 1. Oh, this is minus 1, sorry. This is minus 1. Okay, so now it's correct. Now minus 1, 1, 1, 1 minus 1. That will be minus 1, minus 1, minus 1. That gives me minus 2, not equal to 0. So y1, y2, y3 are linear independent. I can do this trick since they are solutions. I know if they are solutions, then the Wronskian either it's equivalent to 0 or it cannot be 0. So now they are linearly independent. Now I need to solve for the initial condition. So I have the general solution will be y equal c1 y1 plus c2 y2 plus c3 y3. Since they are solutions, 3 are linear independent, and the equation is the third order. We know if we have 3 linear independent solution for a third order differential equation, then this will be general solution, just a linear combination, which is this. What is it? Cosine x plus c3 sine x. Now we need to work out this initial condition. So let me give another page. So this is my general solution. Let me rewrite it. I think I started with the cosine. Right. Yeah, usually do this. I have the condition y at 0 equal 1, y prime at 0 equal 2. y triple prime at 0 equals 3. So I need y prime. Also, I need y double prime. Okay. Now do the conditions. Y at 0 equal 1. So you have what? C1 cosine 0 is 1 plus C2. That's equal to 1. That's the first equation. Y prime at 0 equal 2. You have what? C1. This is 0 plus C3 equal to 2. Y double prime at 0 equal 3. So you have what? C1 minus C2. This is 0 equal to 3. So you can add these two. Let me call this 1, 2, 3. So 1 plus 3, give me what? 2C1 equal 4. C1 equal 2. If C1 equal 2, substitute in 1 to get what? 2 plus C2 equal 1. So C2 equal minus 1. And substitute this in 3 in 2 to get what? 2 plus C3 is equal to 2. So C3 equals 0. So it will be my solution. Y equal C1 is 2, 2ax. C2 is minus cosine x, and C3 is 0. And that is the answer. Yes. So this differential equation, this is non-homogeneous, but the particular solution is very clear. I can write the particular solution as minus x. If I put minus x, this will be 0 and minus, then yp prime will be minus 1, so minus times minus. So when I have the non-homogeneous, very clear, no need to do any calculation by inspection. Because of that, I put it here. So now I need to find YC, for this, for the homogeneous equation. So I have the auxiliary equation. That will be what? R cubed minus R, which is R squared minus 1, which is R minus 1, R plus 1. That's equal to 0. So R will be 0 plus or minus 1. So it is YC, C1 AX, C1 plus C2 AX plus C3 EX minus X. What will be the general solution for this equation? Since I know YP, this one is Y equal YC plus YP, and that is this. And I know YP easily, just by inspection, minus X. So that will be my answer, which is this. Yeah. Yeah, let me do this one, then I will stop since we open it. Okay, if YP is a particular solution of the differential equation, find 2a plus. Its particular solution of this, it will satisfy this. So I need just to substitute it. P prime will be a, YP double prime will be 0. So I need this times 1, this times 7, this times 12. So I have YP double prime plus 7 YP prime plus 12 YP. That should equal to what? This is 0 on us. That will give 7 A plus 12 AX plus B. And that should equal to 12X plus 19. So what I have 12 AX is the coefficient of X plus 7A plus 12B. That will be equal 12X plus 19. So coefficient of x from this side is 12a. From this side is 12. So a equal to 1. The constant from this side, 7a plus 12b. From this side is 19. A is 1, plug it here. So I have 7 plus 12b equal 19. So 12b equal 12. So b equal 1. I got b, I got a. So 2a plus 3b will be 2 times 1 plus 3 times 1, which is 5, which is this. Yeah, let me stop the recording. Thank you.